Okay, so here's the last of a 3-part video series for the lab bench problems from 827. So we have a graduated cylinder, empty, it's this. When we add so many milliliters of acetone, the new mass is this. Calculate the mass of the acetone. So it's going to be the final mass minus the initial mass. So it's going to be mass final minus mass initial equals the mass of the acetone, which is going to be 95.33 grams minus 73.74 grams, and that's going to equal 95.33 minus 73.74, 21.59. And I have the correct number of significant figures. So right now it looks like my SF is 4. Calculate the density of acetone. Density equals mass divided by volume. So the mass is 21.59 grams. The volume is 15.45 milliliters. So that number divided by 15.45 equals 1.3974 grams per milliliter. I have 4 significant figures, so 1, 2, 3, 4. I'm going to keep that much. It says I round off, so it's going to be 1.397 grams per milliliter. What is the percent error if the actual density is that? So it's absolute value of true value minus experimental value divided by true value times 100. So it's going to equal 0.7845 minus 1.397. And these are absolute values, and the unit here would be grams per milliliter divided by 0.7845 grams per milliliter times 100, and these units will cancel out. And so 0.7845 minus 1.397 equals divided by 0.7845 times 100 equals, and I get that my percent error is 78.075%, which is going to be equal 78.08% because I have 4 significant figures. And that's my final answer. Okay, convert so many miles to meters per second. So you start with 75.5 miles per hour. In 1 mile, there's 5,280 feet. In 1 foot, there are 12 inches. And on the board I had that 1 inch is 2.54 centimeters. And there are 100 centimeters in 1 meter. And I've gotten to the unit I want, so I'm done with converting the numerator. Now I got to take care of hours. In 1 hour, there are 60 minutes. And hours cancel. And in 1 minute, there are 60 seconds. So I promise you this is the best way to do this. And if you do it my way, you will always get the right answer. If you try and do it yourself, it's going to be a problem. So let's just clear all this. I'm going to start with the 75.5. Since this is in the top, I multiply times 5,280. This is in the top, multiply again. This is the top, multiply again. This is in the bottom. So now we're going to divide. Now we're going to divide. Now we're going to divide. And now's the only time we hit enter. We don't do it any other time. So now we took this, times this, times this, times this, divide, divide, divide. I'm double checking my work to make sure it looks reasonable. It looks reasonable to me. I have 3 significant figures, so I'll have 3 in my answer. So I would write here that it's 33.75, and that's meters per second because minutes canceled. And so that's going to be 33.8 meters per second. And for the last problem, same sort of idea, 97.2 kilometers per hour. And in 1 kilometer, there is 1 times 10 to the 5th centimeters. And then there's 2.54 centimeters in 1 inch. And in 1 hour, there's 60 minutes. And in 1 minute, there's 60 seconds. So I'm ready to calculate. So 97.2 times 1 second EE5 divide by 2.54 divide by 60 divide by 60 equals, I get 1062.9. And let's look at our units. Minutes cancel with minutes, hours cancel with hours, kilometers with kilometers, centimeters with centimeters, and that's going to be inches per second. I have 3 significant figures, so this is going to be this number. Okay, I hope that helped. Let me know if you need something else.